Hello, everyone. I'm excited to have on stage right now Suigen Koide, the head of MLOps and Gen AI at Woven by Toyota. He spent 8 years building Toyota's machine learning environment from the ground up, focusing in ML model development, scalable training infrastructure, and MLOps pipeline design. So give a round of applause to Suigen.
Uh, uh. Hi, everyone. I'm Sugen Koide from Woven by Toyota. Today, please let me introduce our journey towards zero traffic accidents, and specifically how we built a video AI agent for automated driving. So let's dive in. At first, let me introduce myself. I am currently the head of Dev Boost World Understanding ADAs at Woven by Toyota. And over the past 8 years, I am building Toyota's machine learning environment for automated driving from ground up, almost zero. And recently, I've been focusing on the innovation with generative AI in the automotive industry. And outside my work, I really love the travel. I once took a gap year and traveled all around the world 1 year with my backpacking and playing guitar. So here's today's agenda. First, the road to zero. Why automated driving matters. Second, finding the traffic jam. How we launch the AutoTriage by spotting a key bottleneck in the ADAS development. And third, from stuck to success. How we overcome challenges and build a video AI agent. So let's dive in. Let me start with section 1. The road to zero. Why automated driving matters. 2 people every minute. To everyone here today, what do you think this number means? Do you have some ideas?
2 people are in an accident every minute.
It's pretty gross. This number, 2 people every minute, represents life lost in traffic accidents. Every year, more than 1.3 million people dies in traffic accidents. And for me, this isn't just a statistics. When I was 4-year-old, I was hit by a car and I nearly lost my life. I ran over across the street toward my mother near the bookstore. And in the next moment, big truck was approaching. But bang. Basically, everything went dark. I was unconscious for 4 days. My grandfather stood on my bed, near on my bed, and begging me to wake up. My mother was overwhelmed with guilt and asking herself why she hadn't held my hand. And now I have 4-year-old daughter, so I can feel what my parents felt at that time. Traffic accidents just don't have the victims, they shelter entire families. And nobody wants to cause accident, right? But one moment of the distractions, someone's life changes forever. And this is still happening on the single daily life. Toyota's ultimate goal is zero traffic accident. And I will continue to working at Toyota because I believe in these missions, reducing traffic accidents and save human lives. But the question is, how do we actually make it happen? To achieve zero traffic accident, automakers have spent decades improving vehicle safety. And one of the most advanced efforts is shown in this video. Imagine you are driving. A suddenly car cuts into your lane. The system detects a risk, avoids a crash, and steps into the help. This is a future we are building, automated driving, where humans and cars work together to prevent accidents. Then how do we build automated driving? We start by understanding how human drives. Driving breaks down into 3 parts: perception, planning, and control. Perception means seeing the world, like spotting a cyclist up ahead. And planning means deciding what to do, like steering to avoid them. And control means taking action, like actually turning into the wheel. To build automated driving, we translate all 3, perception, planning, control, into software. So how do we turn perception planning control into software? Perception uses sensors like a camera, lidars, processed by machine learning model to understand the environment. Planning considers not just our car, but also other vehicles, pedestrians, cyclists. And the controls must steer one-ton vehicle safely and smoothly in real time. Building this technology isn't easy, especially with a personally owned vehicle with affordable price. It requires complex, large-scale software development to meet high safety standards of driving. To make this possible, by Toyota was established. Our mission is to drive a future of movement and enhance well-being for all. So now let's move on to part 2, finding the traffic jam and launching AutoTriage. To accelerate automated driving development, we started a generative AI proof of concept project. And this is the development workflow for automated driving. We start by collecting real-world driving data. When bug is detected, it's uploaded to the cloud. Then we classify the issue, improving the system, run simulation, doing the real vehicle testing, then finally deploy the fix by over-the-air update. But when we map the full workflow, one major bottleneck stood out: human triage. And what is a triage? Triage is a process of reviewing driving logs to find the root cause of system failures. And here is a short example video that shows how triage works in practice. So this is a triage explanation videos, and basically this time we explain about the detection, false positive detection of a car ahead in the ego lanes. So right now, the system is driving in the autonomously, and suddenly it stopped. And we needed to debug this issue. So, our human expert is basically checking frame by frame, checking the video, sensor logs, what's going on in the system. Perception is wrong, planner is wrong, controller is wrong. Maybe there's some, issues. Then this time, we saw something on this, synthetic visualizer there, phantom car. However, in real cameras, there's no car, right? So basically, this is a typical one of the examples of the detection issue, which is pretty, easy to understand. Then this time, phantom car is coming to the ego lane. Then system, then move to the next part. Then now system stops. So basically, this is one of the example of our bugs, and we have a really a lot of bugs, really lot of categories of bugs, and we needed to basically classify this bug into the hey, perception, you are wrong, so please fix it. Hey, planner team, you are wrong, please fix it. Hey, controller team, you are wrong, please fix it. So we needed to do the bug classification task so that we can fix, basically assign the bug ticket to the specific teams. So we kicked off AutoTriage with a simple idea. What if we just show the video to Gen AI? We tested on a few examples like this one. The input was driving log video, and Gen AI watched the video and predicted the root cause. And in this case, the ground truth was loss of perception of green traffic light. And the prediction was unable to detect green traffic light. Pretty close, right? So it seems to be working. So now let's move to the part 3, from stuck to success, building a video AI agent. So at first, it seemed like AutoTriage had succeeded. But when we look closer, we found critical misjudgment. In this example, the prediction was unable to detect green traffic light. But the ground truth was loss of perception of green traffic light. And they sound similar, but actually belonging to the different bug categories. And this is just one case. Here is other many traffic light related to bugs, and even just traffic light related to bugs. So bug classification is complex and nuanced, even within a single category, and we have a lot of different categories as well. So we try to improve the performance of AutoTriage, but we hit the roadblocks of every front of AI agent development. This is the most struggle project I ever worked. So data wasn't ready, prompts were too complicated, model struggled, and experiment of course scattered. So let me walk you through each one. First, the data. Only low-resolution videos were attached to the bug ticket. The high-quality logs, videos, reused and reviewed by humans were not actually saved. That's because triage was a manual process, focusing on the human investigation frame by frame. And second, the prompt. Prompts are hard to write. As an AI ML expert like us, we knew various Gen AI techniques, right? But in triage, in this domain, we didn't know anything in the domain. So we even didn't know where to look or what to tell the model. Without domain knowledge, we even couldn't write prompt by our own. And third, the model. Multimodal models struggle, limited inputs, and shallow understanding. And for example, at the beginning of this project, GPT-4o had just launched maybe 1 day or 2 days ago. Then it mentioned video support. So we thought video AI agent might be possible and kick off this POC. But actually, GPT-4 didn't support video input yet, and uploading over 10 images caused input errors. Then we switched to Gemini, but Gemini even struggled to recognize the color of traffic light. It says, this traffic light is red, but come on, it's clearly green. So lastly, the experiments. Experiments are scattered, and of course, result is saved in Word, PowerPoint. Microsoft made a great technology, right? So it was hard to track and slowed us down. So after 1 year, no result. And Steven Moore hit the rock bottom. And people start asking, should we quit this project? And our answer was no. No, we won't give up. And instead, we divide and conquer the problem. So just like the algorithm, let's break the bigger problem into smaller ones and solve each one. Then combine to the solution. So let's go by step. So first, data. To fix low-resolution video issue, we built a high-resolution video pipeline, and now Gen AI can finally see what human triagers saw. So we have a much better input to the Gen AI. And second, the prompt. To fix the prompt issue, we tightly collaborated with domain experts. AI ML experts like us, again, know how Gen AI works. But only domain experts know what actually really matters in that specific domain. So we wrote better prompts and designed better systems together. And third, the model. With the latest model, we finally unlocked detailed video analysis. We use Gemini 2.5 Pro, a multimodal model with reasoning. And it watched a video and responded like the ego vehicle is driving in autonomy on the highway. And suddenly, phantom cyan box is appearing in the ego vehicle lane directly ahead. This level of video understanding wasn't possible before. And lastly, experiment. To improve experiment tracking, we moved everything into the WNB Weave. And today, I would like to give a especially big thanks to the WNB Weave team. They added the video support just for us for this project. So now we can track all experiment with video in one place, just like this. Then here is no car on the left. And basically, Gemini can understand that object is not in the real world camera, then link to the correct bug ticket. And finally, AutoTriage works. After 1 year of effort, we are now seeing high accuracy on the most frequent bugs. And as a next step, right now we are moving from single agent to a multi-agent with a LLM as a judge. So here's how it works. We start with a new bug. It links text, images, and videos. And the triage agent compares it against the existing bugs using the expert-made expansion video and prompts. And this is most important. This determines the accuracies. Then we ask the judge, "Are you sure?" And if the judge say yes, we link it to the known bug. And if not, it go back to the triager toward another path. So this multi-agent setup will improve accuracy and scale our bug triage workflow. And this is the future of triage. With AI-assisted triage, we can go 10x faster with the same team size. And finally, I'd like to share key takeaway for building an AI agent. First, data is 95%. When deep learning became popular, Andrew Ng said that data is food for AI. In production ML system, 80% of our daily work is preparing high-quality data, and only 20% is basically training model-changing configuration. With Gen AI, I think this ratio has even shifted. Now it's 90% is about data, 5% is about data, because since most of the case we use Gen AI with in-context learning, fine-tuning, so the importance of high-quality data is ever growing. Second, collaborate with domain expert. As AI ML expert, we knew various Gen AI techniques. But to solve real-world challenges in a specific domain, we need domain knowledge, and only domain experts have that. So how closely we can collaborate with them to design good prompts, good system determines any success of any AI agent project. Third, never give up. GenAI model evolves every 3 months, so what was impossible 3 months ago may be possible today. So never give up, keep digging. And finally, experiment. It's simple. Let's use WMB view. For future work, we started with triage, but this is just the beginning. My goal is to expand the AI agent across the entire ADS development workflow, from data collection, validation, and deployment. I envision AI agent supporting every step, helping us to build a safer, automated driving system faster. And ultimately, this is why it matters. It may take decades, but as a Toyota, we are working towards zero traffic accidents. And personally, I want to build an automated driving that could have saved my 4-year-old self. And lastly, I'd like to thank my teammates who helped this presentation. At Woven by Toyota, we are building machine learning model to reduce traffic accidents and save human lives, and we are hiring. So if you're interested in let's build a future of safe mobility together. So that's it for all today, and thank you very much for listening.